Welcome to the Passive House podcast, brought to you by Passive House Accelerator, a catalyst for zero carbon building. For news, inspiration, and connections from all flavours of Passive House, check out passivehouseaccelerator.com. Sign up to receive regular updates about events, get your technical questions answered, and contribute to the community forum. There's loads of free information for experienced professionals and people just starting out on their Passive House journey. We hope to see you at one of our construction, tech, or weekly Global Passive House Showcase webinars. In the meantime, here's this week's Passive House podcast. Well, welcome back to another episode of the Passive House podcast. I'm Matthew Cutler-Welsh, coming to you from Auckland in New Zealand.
And I'm Zach Semke, coming to you from Seattle.
How you doing, Zach?
I'm well. How are you doing?
Good. It's the end of summer here. Summer's finished. It's finally over.
Oh,
we're into autumn.
How did that happen?
Well, yeah, it's March already. Yeah,
I see.
That's what happens.
It's been raining ice water in Seattle for the last few days, but so it doesn't feel like spring yet, but we're getting close. Close.
Things are cooling down, but things are also going a bit crazy in this part of the world. At the time recording, things are not going well in Sydney, New South Wales, and certainly in Queensland. Big storms up there. And certainly very out of the ordinary events. You know, these are not normal events, and there's going to be massive. I mean, there already have been very serious consequences and some tragic outcomes from that. And there's going to be a lot of heartache to come, I think, as the water starts to subside from that, and then people try to put things back together. But I always struggle with the analysis of the once in a however many years. I heard one reports of saying once in 1,000 years or once in 800 years. It's kind of meaningless, those sorts of statements, because it's based on what was. And who knows, what might have been considered a once in 1,000 year, which is really not that. It's more, you're actually saying it's a less than 1% probability per year. But that's all going to change. We're going to see a lot more. We are seeing a lot more.
Yeah,
of
it's
these,
already changed.
Extreme weather events. So, it is tragic, and it's also something that we're going to have to get used to and start doing something about.
Right. And then just this week, the IPCC released its latest report on the state of the planet and the severity of the climate crisis and the rapidly dwindling window of opportunity we have to stave off some really, really serious consequences. So the time is now to be acting.
It is, and I'm doing a bit of a course on some climate change stuff at the moment relating to financial disclosure. And one of the opening statements of that, one of the sort of setting the scene, is the requirement for really to halve our emissions by 2030 in order to stick to that 1.5 degree change on average. And that's not very far away, 2030. And where even the policies that we have in place don't get us there. So even if we were to implement all the policies that exist right now, we would not come anywhere close to reducing by 50%. So we need even more stringent policies, and we actually need to follow through and act on those policies, and we need to do it pretty quickly.
Indeed. We're also, I think should mention that we're also in the throes of or witnessing Russia invading Ukraine and a reorganization of geopolitics and power and who knows where where all this is headed. So also a reminder of how really negative change and also potentially positive change can happen very quickly in really unpredictable ways.
Yeah.
So it's just like, I think we get a sense of, well, I understand how the world works and how things are, moving in one direction, and then some unexpected things can come in, swoop in, and kind of change the rules of the game. So yeah, it is a really crazy week for sure.
Yep. But as I said to my kids the other day, let's focus on the things that we can influence and that we can change, which is significant on the scheme of things. If we think about what we do and the industry that we're in, the people that work in this space, we do have the potential to do some really good stuff that can help across a variety of things, certainly help the climate, but also if we think about energy, we talk about energy dependence and resilience, doing good building can all contribute to that. So we do have the power to change things, and that's a good place to be, is to think about the sphere of influence that we do have as professionals and as people. So we should get into this week's episode, because we've got a very exciting project here in Auckland that will be talked about, has already been talked about, and will continue to be talked about for a little while. But before we get into that, let's thank our sponsors.
Indeed. So everything we do at the Accelerator, including the podcast, comes thanks to the support of our sponsors. So a big thank you to our founding sponsors, 475 High Performance Building Supply, Baxt Ingui Architects, Glavel Foam Glass Gravel, Minutair All-in-One HVAC and Dehumidification Units, Mitsubishi Electric Train HVAC US, Partel, Rockwell North America, Stocorp, and Zola Windows. Thanks also to our champion sponsors, Icon Windows and Doors, Proseco, and SIGA. And thank you to our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority.
Awesome. So this week on the show, I've got an interview that I did a little while ago with Pablo Sepulveda. So I'm going to really mess up Pablo's surname. Apologies for that. Pablo is a passive house designer, and he's been the main passive house consultant for a really exciting project here in Auckland. So in New Zealand, we have a social housing provider which rebranded, renamed themselves a few years ago. They were Housing New Zealand, but now they're called Kāinga Ora, Homes and Communities. And they have gone through much more than just a name change. They've really shifted the focus of what it means to provide social housing across all of New Zealand. And the culmination of some amazing work that's been going on there, and some really great people that now work at Kāinga Ora, is this project called Ngā Kāinga Anamata, which is Homes of the Future. And I honestly think that this is a fantastic example. If this is the future of housing in New Zealand, then this is a really positive story, and I think there's no reason why it can't be. To date, we've seen most passive houses in New Zealand be privately owned, single, standalone houses, and I think that's fairly common around the world where passive house gets started. But what we're seeing now is that branching out, and we're getting more typologies of passive house projects, and that includes social housing built to the passive house standard. And that's exactly what this project is. It's doing a lot more than just passive house. Kāinga Ora are using it as a way of exploring the best way to provide passive house, the most cost-effective way. They're looking at different typologies, different building materials, all on this one site. That's going to put 30 new homes within 5 3-level apartment buildings on an existing, so it's a brownfields development in the Auckland suburb of Glendowie. So that's a fairly long introduction, but I think it's important just to paint a picture of why this is so significant for New Zealand, and also I want to do a shout out to the work that Kāinga Ora is doing. A lot of people are involved in this project. Jason Quinn, who we've had on the show and be familiar to lots of people, has been involved in this. Passive House Institute, L. Ron Burrell has talked about it quite a lot as well, and there are many, many others who have a part to play in this project, and will have a part to play, because this is still at design stage at the moment. It's going to be a couple of years. So anyway, Pablo, interestingly, is not actually based here in Auckland. He is a architectural, sustainable and integrated design professional in Victoria, Australia. He works at Aurecon, and he is part of the design team for this project. So we caught up with him recently to talk about Passive House and specifically about this project. So here he is. Here's my interview with Pablo. Hey, well, thanks for your time, Pablo. Appreciate that. Let's jump in and we're going to go straight into talking about the Kāinga Ora project. Now, you're based in Melbourne, but working on this pretty groundbreaking project in Auckland. How did that come about?
Look, it came like an incredible brief that any consultant wants to read. I think that's the first thing. When we were contacted by our colleagues there in Auckland, and they sent us the brief, we said, "Oh, we have to get into this." It was very exciting. We don't have many opportunities to do a R&D project than you have a research like this. And then another thing that was very exciting is that the digital tools were key to get this project working. So the brief was fantastic, and we're very excited.
So describe the project for those that haven't seen it. There will be some that are very familiar with it, but others who don't know what we're talking about. Can you describe the project for us?
So this is a social housing, right, for Kāinga Ora, social housing in New Zealand. They are going to do this project that they are going to build 5 times the same layout, the same building. That is a 3-story, 6-apartment building. And they're going to build it with different construction system in the same site. So it will be 5 buildings that will look the same, the layout the same, but the construction system is different. So it's precast concrete, CLT, light timber frame, light steel gauge, and an hybrid one that the design team developed during the design development. So there's a lot of R&D in this. I mean, Kāinga Ora have been working with it for, I think, a long time. They're going to look at different things, such as embodied carbon of the different system, operational carbon, of course. All these projects are going to be, the goal is to certify Passive House, and we're on track for that. And then there will be a lot of monitoring. And another interesting aspect of this project is the industry engagement. So they have been talking with the local industry. The idea is to lift up the game and include them in this transformation of the building sector in New Zealand. So
I want to go back to the scope. Because there's so many people involved with this project. How does it work in terms of what you get to work on? Because you're not the architect of the project, but you have an integral part into the design. So when you when you got to look at it and when you got to do the analysis on it, how developed was the plan? What did it look like? What sort of information came to you at that point?
So I would say like the layout of the apartments were already set. We didn't have any implication on that. That is context architect that developed it. We got the plans and the elevation and the section, and based on that, we gave a little bit of a feedback in terms of the passive house. And in terms, we did a quick analysis in terms of form factor and window wall ratio, and like start looking at that model. So our implication there was a feedback in terms of that. We said like we think that probably form factor can be optimized, but this is the layout hasn't moved much. I don't think it had much. It's still like the same layout with some tweaking, but it's more about the detailing of that and the detailing of the different construction system that there was the design development. So it was more like at that scale, our implication, trying to get that right and giving some feedback of some risks. For example, overheating, that we thought that could be an issue for this development for the different system.
So you did the PHPP analysis, the energy modeling of the whole project?
Yes, yeah. So there are, at the very beginning, we have just one PHPP. So the buildings are slightly different. So that's a little bit annoying because you have to do then, at this stage, we have 5 different design PH or 3D models that is slightly different. And they're slightly different because of the thickness of the walls change, depending the construction system. But also there is some town planning considerations. So the roof changed a little bit, right? So we have slightly different buildings which need a different modeling. But at the very beginning, we have one simplified, one fit all, I would say, to give a quick feedback, and based on that, we start working with the architects and the design team.
And the architecture team are pretty experienced in energy efficient building, so it's not their first attempt at an energy efficient design. But have they done passive house before?
So they have in-house passive house experts that have done passive house. So Aaron and Alan, the architects that we're working with, a colleague of them, Ben Frost, that was giving as well some insight and some feedback of what we were doing. So yeah, that was a pleasure because they get on the observation we made very quick on, and they understood from the very beginning what we were doing. So they were experiencing that and with a very good internal support group.
Yeah. How does this compare to some of the other projects that you're working on in Australia or elsewhere?
Look, I think it is a little bit more complicated.
Yeah.
Well, first of all, this is social housing, right? So there is the consideration of optimizing everything. So you really you have a very restricted field of game, right? And then the project I have done in the past, that is 2 projects for Monash, that is a Woodside building for Monash, and the student accommodation Guildhall for Monash as well. Their buildings are bigger, right? So we're talking about 5 system. It is around 1,000 square meters TFA, and the other are 5 times or 15 times bigger. And people are surprised when I say that it's more difficult to do a passive house that is a small scale. To do a detached house is harder because the thermal envelope, the form factor I was mentioning to you before, make it everything more complicated in terms of insulation, in terms of window wall ratio, it's less forgiving. And we have done the comparison with the other projects, and the numbers speak by themselves. I mean, TED, I don't know, have over a 50% glazed area, something that you could never do in a multi-story, like little social housing project like this one. If you compare, so we are around 22% window wall ratio for this project. So kind of the half of what we have for TED, and then it's more stringent with the facade airtightness. So everything is more complicated. When I said that this project that is smaller is more complicated than doing big project, people get surprised, but that's a physical fact.
What's the size? So these are are they 3-story?
Yeah, 3-level walk-up.
And we've got, so it's going on a site where there are 8 existing state homes, and there's going to be a total of 40 apartments that are built on that site, spread across the five buildings. So three-story walk-ups, 5 buildings, and is it 30?
So it will be 30 yet. So it is. There will be more buildings that they are going to be built by Kangaura, but the ones we were working, there are these 5 3-story walk-up that has 6 apartments each. So there will be 30. That will be 30 apartments.
Right, and then there's a couple of other buildings that are going to be on that site as well. And so just 2 bedrooms in each apartment. So they're quite small.
They are quite small, yeah. They're quite small. And then, I don't know, that there was the whole conversation about the occupancy, right?
Yeah.
The occupancy. So the Kangaura is expecting 2 adults and 2 to 3 children in one of the bedroom.
So 4 to 5 people, but still only 2 bedroom.
That's
apartments.
Right.
Yeah. And I guess the context of that is we have a housing shortage. A lot of places do have a housing shortage. So this is about intensification. Turning 8 houses into 30 apartments plus some other dwellings on that same site. So potentially housing many, many more families on the same piece of land that the public housing organisation owns, but doing that in the best way possible, which they've decided is passive house, which is pretty significant because I'm not sure if it'll be the first passive house social housing development by the time it's finished, but it'll be one of the first. What's the timeline for this project? Because those existing houses are still on that site at the moment, aren't they?
So yeah, normally we will start the building site next year. So we are waiting for the certification, and everything is like set up for starting next year. If I'm not wrong, will be delivered 2023.
Yeah.
So yeah,
2 to 3 years away, depending product supply and pandemics and everything else.
Yeah, but now the interesting thing is that Kangaura have done very big work, stimulated the local industry. So that's something that probably that will help in this context, which is quite complicated with the supply chains and getting the materials across the world.
Now you mentioned the importance of working with the local industry and also innovation, and the fact that it's a research project, it's a pilot project. Why do we need to do research? Why do we need pilot projects when Passive House is 30 years old and there are thousands of examples of apartment buildings built to Passive House standard around the world?
That's a good question. I mean, like the R&D project is not only around Passive House; it's around many different things. right? And they're using passive house to get their goals there. Right? I mean, if you're aiming to do net zero carbon buildings, passive house, like in my experience, make a lot of sense because you're targeting the operational carbon and reducing it in a way that is quite efficient. I mean, you see what you calculate is what you generally get. So for me, it's a logic step in this program. And then there are all the other research that are around. But I think it's a good way to stimulate the local industry. It's like, look, this is where the industry is going. That's one thing. And another thing is to demonstrate that it's possible to do it now. Yeah, that's a very strong message across New Zealand and in the region. I mean, I think this will have an impact not only in New Zealand but in Australia for sure.
So the research, the local innovation is not so much about if passive house is going to work, because we kind of know it's going to work. It's about how to do it locally with the contending environment that we have, the local products, materials, the skills, the aesthetic, all those elements.
Yeah, I would say that, and also is to demonstrate one thing that generally people get a little bit like passive house, that thing that they use in Europe.
Yeah.
For that climate is to show like no, that's that the benefit they get is benefit we can get as well. We have to adapt it. I mean, you have to design it in a way that you are going to get that incredible energy saving. I mean, we have calculated, and the average in, for example, heating demand for this building is 80%, which is incredible.
Right? 80% saving against
heating demand.
Doing just a standard code compliant house.
Yes, yeah. So, one part of the task, one part of the R&D of this project was to compare what Kāinga is like traditionally doing, and with the different construction systems, and compare it to what we are doing in this project.
Yeah, which is interesting because Kāinga already builds slightly different. Possibly parts of it are slightly above the building code, but they have their own sort of requirements of specification. So they're already, in some ways, already building a bit better.
Yes.
But you're saying this is 80% reduction in energy consumption or heating load.
For
anyway.
heating demand. Yeah. Heating demand. And the loads is around 70%. So we have this 5 PHPP, but we have one version that is with the classic number, right? The classic U value. So we have 10 PHPP, and the exercise was to compare them. There are some that the starting point was much better than others, but that's the average improvement. Is 80% in
there must be. Is that painful, or is it quite good fun to do a PHPP model on a standard New Zealand specification? It must be a pretty terrible result.
The results are not great. It's kind of, but I think we have seen, we see the same thing here in Australia. So it's not shocking, but it's also very rewarding because that when you do it and you start looking at the numbers, you say like, look, this is the effort we're putting, but this is the gain we're getting.
Yeah.
So it's not only in terms of energy efficiency. I mean, like the comfort that they are going to have, the well-being they are going to have, the people that are going to live in this environment is fantastic.
Benefits is going to be huge. I mean, so many, not just public housing, but just all housing in this environment has mold everywhere because we have quite high relative humidity in the ambient environment.
Yeah.
So to be able to maintain indoor air quality of a comfortable temperature, but also keeping it between 40 and 60% for most of the time is going to be huge.
Yeah, no, I saw recently, like in LinkedIn, that there was a book circulating about moldy house.
Was it Rotonomics?
Yes.
Yeah. Our friend Thomas Van Ramsong from Proclaim is sending out copies of Rottenomics to various people. It's a sad story, but it's one that needs telling. And what we often talk about is that was an issue from moisture getting in from the outside. And we've more or less solved that problem by just building decently. But what the looming problem is moisture from the inside and not dealing with that. And it's not even a new problem. Europe had the same problem. North America's had the same problem. It's when you start accidentally making buildings more airtight without considering moisture control. And, if people just embrace Passive House, all that would be sorted because you have vapor control, airtightness, and good ventilation. And, you're just not going to have those health issues. But we are going to have them on all the vast majority of houses that are currently not being built to Passive House. So it's great to have projects like this that are demonstrating a better way of doing it.
Yeah, no, I think there will be more and more an issue. I mean, we don't have the humidity, relative humidity you have there, but I have seen some residential project having that issue of mold growth.
Yeah,
because exactly what you're saying, that we're trying to build better, and the thing is that when you do one thing, you have to think what is the consequence that it would have in the other aspect.
You can't just keep stacking on insulation.
That's right. Yeah, that's it. So yeah, what Passive House does is you are not picking what you want to do. You have to work all together, right? So the ventilation system is a key component of that to get it right.
One thing we do have in common is heat. How's the PHPP model looking for summer?
Okay, so that's we have Kangaora asking us this question because I had one experience in terms of overheating and what PHPP is saying and the recorded data, and there is a mismatch in this region. So
you've done some post occupancy.
Yeah, it's almost like this is Monash that have done it, and the heating demand and heating load were spot on. The overheating was higher than predicted by the PHPP. Right. And there is something that the Passive House Institute, I don't know, they have done some seminars about it, and they know that there is some limitation in calculating this in PHPP. For housing, it can, like multi-family housing can be even more a problem because you have some areas in your treated floor area that have very low internal heat loads, like the stairways, right? But then you have other places in the house that you will have a lot of internal heat load. And PHPP is an average of a volume, right? It's not a multi-zone. A multi-zone modeling, right? So it will give you an average, but that hide the difference between the different zones. So
right. There's no benefit of having a cool stairwell if your lounge room is really hot.
That's right. Yeah. So and that will not be captured by the PHPP. So we had that conversation with Kangaora, and we work out another methodology. So we did another thermal modeling that is with Energy Plus, and it's multi-zone. And Max Marshall from my team did a parametric modeling that is really, really incredible. 100 of iteration of slightly different things, right? The layout's still the same, but it's adding a little bit of more shading, changing the solar heat gate coefficient here, changing the position of the domestic hot water tanks, for example, was one of the key things to get it right. Like very, very refined modeling, parametrically done, and that get a lot of data. But we're saying, like, if you do this, and this thing add up, because Passive House is such a well insulated and airtight building that whatever you do slightly, the effect will be maximized, but by that envelope.
Yeah.
So we started, I think, with 6% of overheating with the developed design model, And after that parametric design and recommendation, we are less than 1%.
Wow.
But we feed up, we make this digital workflow between the PHP, Energy Plus, iterating many things and feeding one model to each other, because PHP is harvesting a lot of information for Afflixo modeling, for example. So we could take all that data and feed it into this Energy Plus modeling, and do this very like in deep analysis to get a right design. And we were passing under a CIPS standard, the TM52 and TM59.
Right.
And we put as well climate change scenarios. So it was a very thoughtful process.
Now that's interesting. So you're looking at not just the current climate files for Auckland, but you've extrapolated that out to what a degree or so.
Yes,
increase.
That's right. Yeah, that's right. I mean, we didn't choose that weather file. Kangaura wanted a specific file that was pessimistic, and we put it and we fit it into it. And we have
because there are some people working on that as a project, aren't they? Like creating sort of future climate files.
Yeah. I mean, there is a database. You can find those with different databases. There are paid database. Yeah, you can get access. But I know that governments and councils, they are developing the same weather files and get it accessible to the public.
Yeah. You mentioned playing around with different solar heat gain coefficients on the windows. In your design at the moment, is there a standard window, or have you optimized window specifications around the building? So do some aspects have different windows than others?
So I would say that there are there was a lot of coordination with the industry to get this right, because we have to make sliding windows. That's one of the things that I look at the project. The first thing I saw, I said to the architect, I don't think sliding window for passive house will be something that we are going to get there here. Like
it's one of those things that you can have, and you can have it well, but you can't have it well and cheap.
That's right. Yeah. So like we were like, oh, do you think we can procure something like this here in New Zealand?
They exist.
I know that there is product that does that. But if you go to the passive house database of the windows and you have like, I don't know, 100 of windows, and then when you see the sliding window, there are not so many, and they're quite sophisticated. So look, there was a spatial requirement, because as I said, like the apartments are not for Australian and New Zealand standard, not that big, because we have to say that an apartment like that would be like a normal apartment in Europe.
Yeah.
But for this standard, and they didn't want to waste any space, so a sliding door makes sense, because you are not sacrificing a little bit of space to opening that door or door window into a balcony, right?
Yeah.
So those are triple glazed.
Wow.
So we are going to have triple glazed in the balconies, and the rest are double glazed.
Yeah. Well, it's a very exciting project. How did you first get into passive house in the first place, Pablo?
So it was the first time that it was my first project in Australia. So I used to work in France for many years, and
as an architect. You're a trained architect there?
Yeah, so I'm an architect and a town planner that got interested in sustainability, and I realized that all the knowledge in terms of calculation was held by engineers. So I decided to change career and start working with engineers. So I work. They have the keys to design these things and calculate and to understand what is the implication of changing one thing to another, right? So I was fascinated by that, and I started working with engineers in France. and I was part of Elliot, that is Edgy's group, and they are very into doing a competition, international competition with architects, and that's a very quick integrated design process, because you have to get the better design from the whole competition. So it is not only about the architecture; it's about performance. It's about the smart of or the financial smart you can bring. So it's a competition, not like in all sense, right? And when I arrived to Australia, I started working, and the first project that they gave me was the Monash studio accommodation. That is this 150 bedroom studio accommodation for Monash. And yeah, my first instinct is like, okay, I have this is passive house, ultra performant, and I got a little bit scared, and they said like I have to have training, so I was. I was doing my training as passive house designer. Meanwhile, I was developing that project with Claire Perry.
So you hadn't done passive house when working in France. It wasn't until you came to Australia, and then
no. So
and then jumped in.
So I was like kind of used to what I thought I was like high performance, which they're high performance, but this is like next level of high performance.
Yeah.
But it was great to see that they have tools like the PHPP, right?
Yep.
So I was used to do like quick calculation to inform the design team about the performance changes of their design. So for me, it come like in the great timing, because it was high performance, but super high performance and with digital tools. So I think I find it very comfortable doing that. Very stressed, of course, because it's a lot to get into, and
a pretty high profile project.
Yeah. So there was kind of a lot of pressure with that. I could not fail in that, and but it was for me great, because I got in contact with all these great people. And learning for different people that are expert in the matter. So that was great experience.
Do you call yourself an engineer or an architect?
I think I call myself an architect and a fake engineer. Yeah, I mean, like I have learned for engineer. I have a lot of respect of what they do and what they have told me. But yeah, I cannot call myself an engineer.
Yeah.
I always think like an architect. I think that's my fair reflex. And when I talk sometimes, the architects involved in the project, it's like why he's commenting the architecture. Because I'm an architect. I mean, that's come naturally for me to talk about architecture.
It's a great combination. Well, it's great to have your input and all that expertise on these projects. And I think it really speaks to the fact that this is not just about 30 apartments in Auckland, but another step for this region for how to think about passive house in our context of our the need for housing, but also our warmer climate and all the other material supply issues that we have. So it's really, really exciting, and I think it's great to have such an integrated team as well. You know, have lots of different firms. Gets quite complicated, but I think it's going to be really positive for the industry to have so many people involved in projects like this. So keep up the good work. We might have to stay in touch as the project progresses.
Yeah, that will be a pleasure.
And hopefully you'll get to do a site visit.
We will see. Conditions with COVID are changing every day, so I don't know.
Yeah.
I hope that will be the case.
Yeah, awesome. Hey, thanks a lot for your time, Pablo. I really appreciate it.
Thank you, Matt.
And that was Pablo Sepulveda there, coming to us from Victoria, Australia, but talking about the Ngā Kāinga Anamata project, which is based here in Auckland, where I am, not far away from me, actually, the suburb of Glendowie, It's a really exciting social housing project that's going to be built in the next couple of years. What do you think, Zach?
Well, what a cool project. I've always enjoyed hearing about pilot projects, and this one is somewhat unique in that it's also piloting the embodied carbon impact of different building approaches, which I think is a really important contribution. And also, just going back to your back to the words you were saying in the introduction about the kind of groundbreaking nature of it as a piece of social housing, or as in the US, we would call that affordable housing. The affordable housing community can play a really big role in advancing passive house practice and awareness and kind of market adoption. This certainly happened in many different communities in the US. And so I'm hopeful that the same kind of dynamic will play out also in New Zealand, and you'll see more and more of these buildings and take advantage of the advantageous form factor that larger buildings play, as Pablo was laying out in his conversation with you.
Yeah, I remember being inspired by various conference presentations that talked about passive house, social housing projects, or affordable homes, community housing, all different names for very similar objectives, from the UK, from Europe, from lots of other places, and I understand the challenges of getting a project like this over the line, getting the funding, because they are seen as being much more expensive, which is always really hard when you're talking about affordable housing. But when it does get done and you see the benefits beyond just the energy efficiency, but people just having better lives in these places and treating it better because they value it so much more, and then you get all these other downstream or unexpected benefits of people just being happier where they live. There's one classic example of, I don't know if it was a study, but there was definitely an anecdote of a development. It might have been one of the UK ones, where the crime rate and the vandalism basically disappeared when you put people into houses, or you gave people housing that was really, really good, comfortable, healthy homes, just because they respected it and they just valued it so much more that they didn't want to damage it, and they did respect it. So, there's lots of other benefits beyond the environmental benefits of a project like this. So really, really exciting that it's finally happening in New Zealand. Part of me, with all these projects that are quote unquote pilot projects, I have a little bit of a reservation, because I think, why do we need to pilot things when we do have these examples? When I've heard about them for years and years, it's been done, it's been proven. We don't need more pilots. We just need more actual buildings and to do this. But I do, having spoken to some of the great people at Kāinga Ora, people like Pablo, I also appreciate that there's I think there's human nature that you kind of need to try things ourselves, but there is also the reality of supply chains, local products, local ways of doing things, that just because something has been proven elsewhere doesn't make it directly replicable in the building environment. And that's a bit of a shame, but I also kind of appreciate the reality of that. So I think that there is some benefit to piloting things like this, as long as we don't get stuck in kind of doing research for research's sake, and we learn what we need to learn, which we import the understanding that is there and is available, and then we move quickly to the next phase of ramping it up and just getting on with it. Yeah, no, well said. There is something really powerful about it, about the proof of concept, that it can be done. And it is frustrating. I share your frustration. There are thousands of these buildings that have been built around the world. So can't just these local practitioners, trust that and go for it. Yeah. But I've definitely seen that this play out in Seattle, where I live. And
with just kind of a reluctance to take on something new. And I think that as industries go, the architectural engineering and construction industry is fairly cautious and conservative about change, right?
Yeah.
And I maybe rightly so, because buildings are a big deal.
Yeah.
They're huge budgets going into these buildings, and also really important life safety implications of. So there's a lot of caution. One of the upcoming programs on Passive House Accelerator Live, the one that's coming up, not the week that this airs, but the next week. So March 16th, Wednesday, our time, Thursday, your time, is about a project in Seattle called Hobson Place, which is a passive house affordable housing project that was born out of a pilot effort to show that passive house works for affordable housing in Seattle. Then has been traditionally a reluctance among affordable housing providers in my city to embrace passive house, and I think that that's beginning to change thanks to some proof of concept. But yeah, it can be a frustrating dynamic. But I do think that proof of concept can then make a really big difference.
Yeah.
So Pablo slipped in this quote. It was when he was talking about, he started as an architect and then he became more and more involved in engineering. And later he called himself an architect and a fake engineer. But he mentioned that what part of the reason he has so much respect and likes engineering is that engineers hold the keys to design. That because they're the ones who can measure the implications of making one design choice or another design choice, and they have that kind of understanding, and therefore some real power in the process. And I think the cool thing about passive house is that it provides architects with those keys as well. And it is so, I think, empowering for practitioners who then have those keys to be able to play around with different ideas and measure what the impacts are, and realize things like the 80% reduction in heating demand that he was discussing compared to conventional buildings in New Zealand. Yeah,
there's so much power in modeling when you're confident with that model, and that's been proven over and over that PHPP is such a good model for this scale of project, that that gives you a lot of power to you essentially predict the future and figure out how things are going to go and have a look at different options. I know one of the things that they are looking at in a bit more detail, there's a lot of people interested in the overheating aspects, and that's still an area that I think is valid to do more research and explore in Australia, New Zealand, and also some warmer climates, other warmer climates around the world. So that's going to be interesting because I think they wanted to do a bit better than the 10% allowable threshold for overheating, which I think does make sense in places like Auckland. So it'll be interesting to see what comes out of that.
Yeah, definitely. It was really interesting to hear his exploration of that and the kind of the zone by zone analysis they were doing. Both, and this is something that both PHI practitioners and FIAS is grappling with, and their approaches are different, but it's the same kind of problem as how to really dial this in for hot and humid climates.
And the final thing for me, just on that project, is they've kind of already got some of the answers. Part of the purpose was to figure out the lowest embodied carbon options, and because they're looking at different construction methodologies. So for various reasons, they're sort of settling on CLT, so cross-laminated timber, as being one of the best options for overall carbon when you compare that to things like tilt slab, precast concrete. Obviously, that's very carbon intensive. There are ways of working around that, but and I think this comes back to the issue of what's available in your local area in terms of raw materials, but also manufactured products and supply of products and systems. So it's interesting to see how that's playing out. And for me, the really exciting part of that is that those questions are being asked and that analysis is being done, because previously we just said, how can we make the most energy efficient, comfortable building? Awesome. You just throw everything at it and just you put foam in there, you put concrete in there, you use whatever makes it work. But now we're actually thinking, well, hey, it's all well and good having a warm, dry, comfortable, healthy home, but what's gone into making that? And is that making the planet better or worse? How can we have our building and our planet as well? So it's really nice to see that analysis being done.
It is, right? How can we dramatically reduce operational carbon and avoid a significant carbon burp before, right now?
Yeah. All good stuff. So, hey, we'll keep an eye on that project because, like I say, it is in early stages of design and then consenting. So it'll be a couple of years through the construction phase. So it'll be one to keep an eye on.
Yeah, definitely. Looking forward to it.
All right. So we've got a few. You mentioned some live sessions, but I know there's a bunch of other stuff going on at the moment. I'm looking at the very wet Sydney images on Facebook, people standing around watching some ice melt.
Right, exactly. In the midst of some record-breaking torrential rainfall. So the Sydney Icebox Challenge closes up, I think, tomorrow. Is that right? As we're recording this. So when this podcast episode goes live, the results will be in, and we'll know whether the Passive House box or the conventional code constructed box won, and which one has more ice in it. My bet is on the Passive House box. But exactly. I think it'll be really interesting to see the difference in volume of ice left in both of those. And hopefully they won't be floating away, which would make it more difficult to make those measurements. But that's it. That'll be exciting to see. The Icebox Challenge is so much fun. And then coming up this week at Passive House Accelerator Live, we're having a construction tech edition of the show, and we are visited by guest speaker Scott Farbman of DBHMS, and he is going to be presenting about ventilating for healthy indoor environments in Passive House, with the subheader of everyone needs to breathe and eat. So that's referring to the impact of kitchens and indoor air pollutants from ranges and how to deal with ventilation and all that stuff. So be great. He has a number of different design approaches to ventilation design. And then the following week on Passive House Accelerator Live, we will have that project showcase edition that I was referring to. So it's the Hobson Place Passive House Affordable Housing Project, an exemplary building in Seattle. And we're going to be visited by Sharon Libby of Walsh Construction and Greta Chelvite of Evergreen Certified, who will both be presenting about this project. So that's going to be really interesting, I think. And there's lots going on, other stuff going on in the community that we'll include in a link. We will include a link in show notes.
Awesome. So I think that about does it for us for this week, Zach.
I think so. Yeah. Thanks, Matthew.
Thank you. We'll be back again next week with another episode of Passive House Podcast.